In the summer of 1994, the first book I read in electron microscopy was an analytical electron microscopy. And I truly got excited about quantitative X-ray microanalysis. And then the next thing I read was a book, special issue, from the National Bureau of Standards, the NIST at that time, that was about Monte Carlo simulation, the NBS 460 special publication on Monte Carlo modeling of a workshop that was done in 1976. And I was absolutely amazed about the use of the computer to simulate electron trajectories, to model X-ray emission, to perform quantitative analysis of real and non-homogeneous materials. I already saw the value. And then by searching in the literature, I saw a paper by David Joy about the effect of fast secondary electron on quantitative X-ray microanalysis. So I was absolutely amazed. And so I was obsessed by the effect of fast secondary electrons next to a grain boundary, because we have believed that they degrade the spatial resolution, and to model that effect, Monte Carlo simulation is an effective way. So that's why I truly got obsessed by that technique. Well, at that time, the computers were very slow. That's the first thing. Were not as fast as they are now. At the beginning, it was taking a night on a supercomputer in order to get 10,000 trajectories. So that was, I would say, the limiting step, because I had to start from scratch my modeling. So I, in fact, wrote myself all the code without modern text editors, and then I had to fix all the bugs, bugs in the code, and bugs in the logics, and bugs in the physics. And so, because the computer was slow, it was taking a long while before realizing that I have issues and I had bugs. So it took mostly about 2 years to develop my first working code, basically. Absolutely not. They were saying that the computers are too slow, and because of that it would be impossible to use them in a practical way. And I always thought that the computers are getting faster and faster, and now I can realize that this is the case. So, but no, it was not easy. And also very few people were aware about what it can do, so I had to fight against a lot of skepticism.